In today's note, we are going to look at right-angle trigonometry, specifically the tangent ratio. So trigonometry is the study of relationships between sides and angles in triangles. And primarily what this is going to focus on is right angle or 90-degree triangles. So when we're working with right angle triangles, there are going to be three ratios that we'll look at. The first one we're going to look at is the tangent ratio. Now, we're going to have future lessons on the sine ratio and the cosine ratio. The beginning page is going to look very similar, as will the questions. So as you go through those, you may want to skip ahead, but for right now, this is going to be important because this is the first time you're seeing some of this information. So in order to use right-angle trigonometry, we need to label the three sides of a triangle. And this is important because this is going to be the first step when solving trig problems. You want to label the triangles. So we have the three sides are the hypotenuse, the adjacent, and the opposite. So if we have a right-angle triangle, we need to label those three sides. Because it's a right-angle triangle, we should have a right angle in here. So we should see a 90-degree angle somewhere. Now, in order to label the three sides, we need to understand the characteristics of them. The hypotenuse should be a little bit familiar from grade 9, and the hypotenuse is the longest side. So in this case, this is the longest side of our right-angled triangle. Now, in some cases, we may not recognize what the longest side is, or it may be a little bit hard to tell. It may be too close in length to some of the other ones. So another characteristic is that it's always across from the 90-degree angle. So if we can identify the 90-degree angle, which we should be able to, because again, it is going to be a right-angle triangle, we just have to go directly across from it and we'll find the hypotenuse. Now for the opposite and adjacent, we need to have another piece of information. And that piece of information is what we call theta, which is this Greek letter here, or Greek symbol. So this symbol right here is theta, and all that refers to is an unknown or given angle. So the unknown or given angle, and I'm going to refer to it as a reference angle. Because this reference angle is going to help you locate or identify the adjacent and the opposite. So now that we have our reference angle, it's going to be helpful to figure out which side of the remaining sides is the opposite and adjacent. If we were to draw a line from that reference angle straight across to the side across from it, that would be our opposite, because it's across or opposite from our reference angle, which is kind of in the name. So across from the reference angle. That only leaves one other side, which is the adjacent. And the adjacent is adjacent to or beside the reference angle. And the reason that we know it's this side and not the other side, because you could argue, oh, well, they're both adjacent, we already know the one side is the hypotenuse. So it has to be the only other side. So it's important to be able to label these sides because it's going to help us identify what trig ratio to use. And in this case, the trig ratios we're going to focus on is tan. And the formula for the tan ratio is tan theta equals opposite over adjacent. Again, remember theta refers to our angle, and when we talk about opposite and adjacent, we're just referring to basically side lengths, or specifically the side length of the opposite and the side length of the adjacent. The other ratios deal with other pairs or other ratios of sides, so again, it's important to know what is the opposite and what is the adjacent, because that's what we're using with tan. So we're going to look at finding side lengths using the tan ratio. We're going to look at the two scenarios that we could come up with, and then after that, I'm going to let you pause the video to try two on your own. But again, the first thing we want to do is label our sides. So I see 90 degrees, directly across from it has to be my hypotenuse. I see the reference angle that I'm given, or 71 degrees. So from that angle, I'm going to draw a line across to the other side. That's going to be my opposite. The last side is my adjacent, or the other side, the side that's beside my reference angle. When looking at this triangle, it only gives me two sides that are useful. The A, which I'm looking for, and the O, which I have a value for. The hypotenuse doesn't give me anything, so I'm not going to use it in this example, or especially in this note. It's still important to label it to keep with that practice, but when I go and work with the ratios, it's not important because there's no given information. So, because I'm dealing with the opposite and adjacent, I have to use my tan ratio. So tan theta equals opposite over adjacent. So I'm just going to rewrite my formula. Next, I'm going to fill in all my information. So theta is my angle, so 71. O is 18. A is my unknown, or x. What I'm going to do now is I need to solve for x. So in order to do that, I'm going to end up switching the x and the tan 71. So tan 71 is a whole on its own. It's a number on its own. If you enter it into your calculator, you will get one number. So you treat it as one entire piece. So I'm going to switch the two and get x equals 18 divided by tan 71. Now you may be wondering, well, why do I switch it? How is that possible? Well, just as a side, if I have tan 71 equals 18 over x, I need to solve and get x by itself. So normally the x would come up to the other side, be x times tan 71 equals 18. But to get x by itself, I need to move the tan 71 over, so it becomes division, and I get x equals 18 divided by tan 71. So again, just the quick way of doing this to avoid that back and forth of rearranging is just switch the two, or have them switch spots. But again, that's just the reasoning or the math behind that. So now to solve for x, all I need to do is just calculate this, but there are a couple things we need to be careful of before we do that. First, the calculator must be in degree mode. So this might be a little bit tricky, but on your calculator, specifically a regular calculator, you should see either a D at the top or DEG. If you do not see that and you see another letter, maybe a G or an R, you have to change it to put it into degree mode. And you should be pressing, in order to do that, a button that looks something like this. And when you press that, so DEG or DRG with kind of like an arrow or a triangle, if you press that, it should give you the option of either degrees or D, and you just have to change it to that. And that's key because it needs to be in that form. Otherwise, you're going to be finding your answer in different units or measurements. On an iPhone, it is different. If you do use an iPhone, which I don't recommend for Trig because of the way you have to order or organize your calculations, you want to make sure that in the bottom left corner, it says RAD. So if it says RAD, it's kind of opposite. That means that degree mode is in play. And you can see that by if you press the RAD button, you should see that now on your your workspace, it says RAD. And when you press, and this button will have changed to DEG. So when you go back and press the DEG button, that RAD disappears. So it may sound confusing. If you have questions, please email and let me know, or you can Google it, but you do want it in degree mode, and I do suggest using a regular calculator. So back to the solution, this now becomes one calculation. So 18 divided by tan 71 gives us a length of 6.2. So that is our missing length. In example B, same idea. Let's label our sides. So across from 90 degrees is our hypotenuse. I see my reference angle is 64, so across from that is my opposite. 11 is my adjacent because it's beside my reference angle, and it's the last side that I have to label. I'm only dealing with the opposite and adjacent, so I have to be using tan. So even though that is the note on tan ratio, it is helpful to identify what side you're using, and that will be helpful once we start looking at all the ratios together. After I figure out it's tan, I'm going to fill in my missing information or the given information. So tan theta, the theta or the angle is 64. The opposite is x, and adjacent is 11. Now what I need to do is rearrange my equation and solve for 11. Or it's not 11, for x. So in order to do that, I'm going to bring the 11 up, and it's going to multiply. So kind of similar to what we were doing in the last step, except because the bottom is known, I don't need to rearrange it further. So I get 11 times tan 64 equals x. This is just one calculation on your calculator. And I get that x is 22.6 units. So these are basically the two scenarios, or the two different ways of finding a side length. A, if the missing piece is on the bottom, and B, if the missing piece is on the top. So what I want you to do for C and D is, don't worry about the tips at the bottom, we'll come back to that, but try going through and solving C and D. Right, solve that for that missing side length. The steps are going to be very similar to what we just looked at. C is going to be very similar to A, and D is going to be very similar to B. So just make sure you label your sides correctly and plug the pieces into the right spots, and you should see or be able to refer back to the last questions to figure out what the operations are that you need to do. So again, I recommend you pause the video to try this on your own. So coming back to our two last examples, C and D, this is what you should have. So again, hopefully you labeled your triangle correctly, plug the information into the correct spot. Again, using the idea or the examples from A and B, hopefully you're able to rearrange and solve for your two answers, for C, x being 22.6, and for D, x being 29.3. Now the tips, or the two tips to help us with our operations to figure out what to do, if we look back at A and C, when the missing piece is on the bottom in this case, the operation, or what we had to do to solve is we had to switch. We had to switch and divide. So we see we switched these two spots, and then we ended up dividing. For B and D, what we had to do, or the operation that we had to do when the missing piece was on the top, we had to bring up and multiply. So obviously there's a little bit more to it than that, but essentially that's what we're doing in these two scenarios. And the nice thing about trig, when we're trying to find a missing side length using in right angle trig, these are the only two scenarios that we could have. The missing piece being on the bottom, or the missing piece being on the top. So again, these are the two scenarios that you may run into, so it's helpful to know these two tips, and if not, you can always refer back to your notes. What we're going to look at next is finding angles. But before we go into this section, it's time for today's code word. And today's code word is Among Us. So it is Among Us, that is the video game or the mobile game with the imposters and the crewmates. So again, the code word is Among Us. Coming back to finding angles. So when we find angles, we have to use the inverse of our trig function. And the way we get that on our calculator is we have to press second or shift and then tan to get the inverse. So if you look at your calculator here, if we just zoom in on it, we have to hit this second button, and that will allow all these buttons to change to what we see up top. So these little things up here. So if we want the inverse of sine, or sine -1, we have to hit second function and sine and so on. But because we're focusing on tan, we're just going to focus on second function and then pressing the tan button. And this is only for when solving for angles. Because what we're doing, and we're going to practice just a few of the calculations, if I know that tan theta equals 1.56, and I'm trying to solve for my angle, I need to get theta by itself. So I need to get rid of the tan. And we can treat tan similar to an operation. So to get rid of something or to get rid of an operation, we do the opposite. And the opposite of tan is the inverse of tan. So in this case, if I want to get theta by itself, I move the tan over. It becomes the inverse, or tan -1, of whatever's on the other side, or 1.56. And so on our calculators, we calculate this, and we should get 57.3 degrees. Again, make sure that when you're doing this, you're hitting second function and tan to get the tan -1. You're not doing tan to the power of -1. You're not trying to create this on your own. You're using the button, the tan -1 button. For the next example, same idea. If I want to find theta, move the tan over, it becomes the inverse. So the inverse of tan -1 of 2.5 gives me an angle of 61.2 degrees. Even if we have a fraction, so maybe we haven't turned the ratio completely into a decimal yet, it's still the same thing. Move the tan over, it becomes the inverse. Tan -1, 6 over 19. A little bit more of a calculation. But if you're using your calculator, you could enter tan -1 and then in brackets, 6 divided by 19, close bracket, and you get 17.5 degrees. If you're not comfortable doing that, you could do 6 divided by 19 on its own to get a value of 0.3158. I would recommend going at least 3 decimal places, 2 to 3 decimal places, just to make sure that you're not rounding and getting a different degree. But usually I'll take a ballpark, so anything from say like 16 to 18 would be fine for the last answer. Because again, it will change depending on what you round up to. But try to keep at least at a minimum of 2 decimal places. So looking at triangles, if we're given some information and we're asked to determine the angle, we can use our trig. So the first thing we want to do is label our missing sides, or label our sides. So right angle, across from that is the hypotenuse. The question mark, even though I don't have that angle, that's still going to refer, or I'm still going to refer to that as my reference angle. So across from my reference angle is the opposite, which leaves the adjacent beside it. Because I'm dealing with the opposite and adjacent, or opposite and adjacent, that tells me that I need to use my tan ratio. I'm going to fill in my information. So tan theta equals 21 over 20. And now I need to solve for theta. In order to do that, I need to move the tan over. So it becomes tan negative 1, 21 over 20, which is just a calculation on your calculator. And we should get an angle, or theta, of 46.4 degrees. So that is our missing angle. And the nice thing about finding or missing angles using trig is that the scenarios are always going to be the same. You're always going to be given both sides, and then you just have to do the inverse of your function. So in this case, I need to label my sides. So again, across from 90 is your hypotenuse, across from your reference angle is your opposite, and then beside your reference angle is your adjacent. Because again, I'm dealing with adjacent and opposite, I'm using tan, so tan theta equals O over A. Tan theta equals 3 over 4. To get theta by itself, I need to move the tan over, so tan negative 1 of 3 over 4, which again is just a calculation. And I get 36.9 degrees. So again, we can see two different examples, two different triangles, but we're always going to be given both sides to complete that ratio, and then we just have to do the inverse. So there's only one way that you're going to be finding a missing angle using the tan ratio. So again, the main things that you should get from this lesson are how to label the sides of a right angle triangle for the purposes of trig, and how to use the tan ratio to solve for a missing side or missing angle. And again, in the next lessons, we are going to look at the other ratios, but you'll see that it's very similar.